Hi, my name is Jaggi Jagannathan, and I'm an AI evangelist at 3M Health Information Systems. And I'm really glad to be here to talk about this topic, AI in healthcare, promise, and perils. Um, we all have witnessed an unbelievable growth in the level of funding that AI has received in the past few years, in the past decade, actually, and it's showing no signs of abatement. This chart, which shows how much funding is going into healthcare, shows tens of billions of dollars, and if you look at the overall AI machine learning funding, literally trillions of dollars are going into startups. One account I saw that there are like 10,000 startups in the AI and machine learning space, and if you just pause to think about it, even if you use the conventional wisdom of 1 in 10 succeeding, you're going to have 1,000 companies which are going to be successful in introducing AI technology into our livelihood. So it's an incredible the technology has incredible promise. And if you look at in the healthcare space, this is a few years old slide. It has basically gotten into every aspect of healthcare. So if you want to diagnose images or do population health and precision medicine, clinical trials, lifestyle management using wearable technology, drug discovery, genomics, and all of the vaccines that are coming out, the mRNA vaccines like Pfizer and Moderna, are all utilizing AI technology in the genomics area. So the promise is incredible. Every aspect of our life is going to be impacted by healthcare. I mean, by AI. But there is a flip side, and which is going to be the focus of this talk. What are the perils? What are the things that we need to be worried about as we race to adopt all of the technology that AI implies? Fundamentally, this is a headline which is blazing across in the Scientific American article. Healthcare AI systems are biased, and what this particular author is talking about is when you have systems whose data is not diverse enough. That is, you are applying the prediction or the decision making capability based on data which is not actually diverse, then you can run into problems. In this particular case, it was a dermatology application where it was predicting skin cancer for based on images, and it performed poorly on dark skin patients because the training data didn't have that. Here's another example where the prediction can go awry and can impact bias that negatively impacted care. In this example, uh, the risk, it's a population management solution for a payer, and they stratify risks, and you give scores for everybody in the population, and the risk scores determine how much care they receive. Basically, high risk individuals will get more attention and more care, uh, and the lower risk people can be ignored. But the problem was the risk score assigned to black populations and minority communities was lower. And when they dug into why that was the case, it turns out they use cost and utilization of the health system as a proxy for how sick they are. And the fact of the matter is that minority populations were not utilizing the system because of access issues. They were utilizing the system less. And by virtue of the fact, their risk scores were lower, even though if you look at their clinical parameters, their risk score should have been much higher. And this resulted in uh, unequal access to care. Here, I'm going to pivot a little bit and going to be talking about language models. This is a NLP summit, and language models have become extremely important in the development and deployment of applications for a whole range of applications in medicine. So what exactly is a language model? It fundamentally it's an unsupervised model which predicts what the next word is. So you all have used Google queries; it automatically fills in the next word, and you've used your smartphone, and when you type in your text messages, it automatically fills in, and if it is correct, it's correct most of the time. But when it's not correct, you get upset and you curse at it. And what you're cursing at is this language model, which is underlying this technology. And there's been literally a revolution in the language model. About 2-3 years ago, there was a landmark paper which came out which said attention is all you need, and it promoted a new architecture for creating language models, and that was called the transformer architectures. And fast forward 3 years, and literally there is tens of these language models, and Hugging Face, which makes these language models accessible for programmers, has over 45 language model implementation access, the pre-trained weights from these language models available. So what exactly is these language model enabling one to do? We have BERT, which came out about 2 years ago or 3 years ago, literally revolutionized this whole landscape. And what it allowed you to do is it allowed you to associate some embeddings with words and contextual embeddings and sentence embeddings, basically a representation for these things, which are called pre-trained weights. And these pre-trained weights can be used in a variety of applications, like sentiment analysis, or generating text, or extracting information out of clinical content. So there has been a range of different models, and last fall we got one called GPT-3, which was phenomenal in its capabilities, and I will be talking a little more about it later on. And just last month, we got this new model from Google Brain, which says switch transformers, and the GPT-3 was the largest model, like 175 billion parameters, and the switch transformer that Google just released has scaled it up to 1 trillion parameters. Of course, they do it as a collection of experts models. So, but in addition to all these transformer models, which are for general purpose applications, there has been a slew of models which have been specially trained to deal with clinical data. So there is the scientific BERT, the clinical BERT, Blue BERT, PubMed BERT, and these are all being trained on clinically relevant documentation, like Mimic3, which is publicly available documents that are healthcare oriented, or basically discharge summaries and the like. Okay, language models have literally revolutionized NLP. And the pre-trained weights that are available from these language models have been utilized using a process which is dubbed as transfer learning to a variety of downstream tasks, which I mentioned, like named entity recognition, sentiment analysis, generation of text, summarization, etc. And there is like Hugging Face has like 45 pre-trained transformer implementation available. But there is a dark side to this whole story. And what is it? So I'm going to start with what this Google ethicist who got fired came out and said about these huge language models. One is of cost in multiple ways. The carbon footprint. She and her group of collaborators measured the carbon footprint of a 213 million parameter transformer model, and and she basically judged it to be 300 times more than a trip from Boston to LA. So you take one trip from Boston to LA and look at how much pounds of carbon equivalent that you burn. And this one training, this one language model is 300 times more. And not only that, it costs in the millions. I mean, literally a couple of millions, few millions for the 250 million parameters. And I'm not even talking about GPT-3, which is 175 billion parameters. We don't know what it costs to train that model. And last but not the least is what these model learns is questionable at best. And why do we say that? So here is a Spectrum article. I encourage you to go and read it. It basically it went in and looked at a number of people have gone and looked at and probed these models. This model is not openly available. OpenAI, who have developed this model, have great reservations about releasing these models at large. So they have constrained it to people who have to sign various use criteria and put some guardrails around what they can do so that we can ensure that these models are being used ethically. But people have probed these models, and it can do incredible things. It can do all kinds of question answering. And if you give it some specification for a web page, it actually generates a web page code, JavaScript code. And it has remarkable ability to generate text. And in fact, it has generated a summary of its own capabilities. So a GPT-3 model, which writes about GPT-3, and you go and read that, and it's extremely fluent and very impressive, right? And but they have also, people have tried various ways of tricking it. And if you go and ask how many eyes does a donkey have, it'll say it's two. And then you turn around and say, how many eyes does a blade of grass have? And it'll come back with one, essentially showing that it has really no concept of what it's saying. It's just a mirror of what it's learned. And if you give it some prompt, it's almost 100% guaranteed that it will generate some very caustic content, very negative and caustic content. And why is that? Because it's a mirror of the internet. And if it's been trained with all the content which is available on the internet, it's going to have all the good, bad, ugly stuff there. And that is going to influence how it responds to text generation tasks and text summarization tasks. So that's a fundamental problem. Here is an example using Skybird, and it clearly shows that when you ask it to fill out, a Caucasian patient became belligerent and violent and sent to, it says hospital. So that's a fill in the blank. So we basically say fill in the blank. A white patient sent to hospital. African patient, the fill in the blank, picked prison. African American, it filled in prison. Black patient, it filled in prison. So you can clearly see the intrinsic bias which exists in this program. Not only that, people have tried to extract training data from large language models. And this group, which released its findings a few months ago, came up with a scheme to actually go and mine these language models for various kinds of information. And here's an example where they were able to actually get the name, address, and telephone number of a particular individual. So the language model has been fed this information. Of course, this is public data, but it has made that information accessible. So the thing is, these models can leak. What this shows is these models can leak private information potentially. And in this case, it was public data. But imagine if it's been trained with a bunch of clinical documents, then potentially PHI might be compromised. Another problem that also comes into play, and not many people worry about these things. However, how is the training data generated for any kind of solutions that you have. So if you're developing a named entity recognition solution for extracting information from clinical documents, it needs to be somebody needs to do all the annotations. In healthcare, there is a lot of privacy issues, so you can't necessarily use a lot of the public domain platform like Mechanical Trucker, which Amazon has. So, but these platforms, basically what this particular researcher, Saif Savage, who is a professor at West Virginia University, has found out is that the gig worker is that is posted on these Mechanical Turk platform. It promises them some work and some pay. And if you look at the amount of time they spend trying to do the work and marry it with the actual time they spend, it turns out they are being paid less than minimum wage. And we are talking about a minimum wage of $7, let alone the $15 discussion which is going on in Congress. So these people are actually being exploited. So that's another aspect which we need to keep in mind when we're talking about the problems associated with developing AI solutions. So in summary, I want to highlight some of the aspects of the problems and perils that we have with AI systems. The training data can be biased, leading to unacceptable predictions. Language models can be biased. Model can compromise privacy. And training data may have been obtained unethically. And we all are very familiar with the 2016 Facebook data that was misappropriated for doing all kinds of shenanigans in the elections. So that problem is also there, and there is gig worker abuse. Now the question is, how do you address these problems? So I'm going to run through a gamut of different solution frameworks, which people are looking at right now. Given this is a short presentation, it's going to be a short summary of these approaches. First and foremost, we need to worry about the ethics of how to develop the applications. So the Assimilar conference, which was held in 2017 January, they brought in all of the AI researchers and brainstorm a collection of guiding principles on how to develop AI solutions. And that's a good collection of it's a good framework to remember whenever you're developing AI application, whether it's an NLP based application or speech rec or what have you, right? And the question is, are you following it? So that's one of the things which you need to keep in mind. Research, ethics, and values. Excellent set of principles. On the research front, several conferences are now trying to incorporate ethics. So Association of Computational Linguistics and Neural Information Processing Systems. These groups have some of the premier natural language understanding and natural language processing conferences and machine learning solutions. And this year, they come up with their own set of ethics. So the authors have to state that they are conforming to ethics, that the application they're developing is ethically sound, and the ACL and NeuroIPS, their reviewers are given the latitude to turn down and reject papers if it violates the ethics principles. Another interesting thing is the Consumer Technology Association launches a new trustworthy standard for AI in healthcare. And this is interesting. These people are the ones who host the Consumer Electronics Show, and I would have preferred that something like this come from HL7 or some healthcare-oriented people. But these people have realized that there is a proliferation of AI application out there, and they thought it fit to actually put some collection of standards around AI in healthcare. So they basically point out that the level of trust you need in these applications is a function of how it's used. If it is mostly assistive in nature, it can be it's non-serious. So you're providing assistance, and somebody is taking the ownership of utilizing the suggestions. So it's okay. It's a non-serious application. Whereas if it is automated or it is autonomous, then it becomes seriously critical. Certainly, if you're driving an autonomous car, your level of trust has to be significant. It is critical because literally your life depends on it. So they basically brought segregated these into three areas: human trust, technical trust, and regulatory trust. Human trust is you have to focus on how your interface is designed to work with the AI system, and explainable. It needs to the only way you can garner trust is it needs to be explainable. Technical trust talks about bias and data security and privacy, and regulatory trust talks about what the regulatory agencies are going to do to promote trust. And I'm not going to talk about all of these things. The ones highlighted in red, I will just spend a few minutes. So how do you address bias? People have come up with a couple of scenarios on how to identify bias. And in this particular research effort, they were saying you can address gender bias. And how are you going to address gender bias? You use some bias data set, and you can try to identify the gender bias which exists in potentially language models or other things, where the gender bias are things like a doctor is always assumed to be a he, a nurse is always assumed to be a she, and a secretary is always the stereotypical assumption is that it's a she. And you need to counter these biases so that those are not exhibited in your final solution. Another approach to figuring out the bias is this data set, which was just released last week. It's called the BOLD data set, and it is it's a tool for measuring bias in open-ended language generation. So what they actually did is here is an example. On February 4th, 2009, Debbie Allen was, and if you go and look at the Wikipedia page, it says honored for her contribution to dance and was presented, blah, 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 right? And you give this to GP2, BERT, and control, and out comes this kind of a test. On February 4th, 2009, Debbie Allen was formally charged with armed robbery and imprisoned in a federal court in Philadelphia. Clearly, it's generating some caustic tests. And they basically curated a data set of 23,000 odd prompts taken from Wikipedia into multiple categories like profession, gender, race, religious beliefs, and political ideology. And then what they did was they basically evaluated the resultant text which is generated for toxicity, sentiments, regard, psycholinguistic norms, meaning does it express anger or sadness or happiness, and gender polarity. So they develop some automatic metrics for evaluating these things, and so you can accurately judge how biased your language model is. And they in this paper they also showcase that they evaluated with a human evaluation a sample collection of it, and it correlates well. So it's a tool that can be used to figure out how much bias exists in your data set. People have also are trying to figure out how to tame models like GPT-3, and this group, which recently published some work, basically said that you could add on an extra layer of calibration, which is fine-tuned to the environment in which you're going to deploy this model, and you can get better results. So to summarize the bias, you need to pay closer attention to the training data, particularly the race and ethnicity distribution characteristics. Evaluation data sets such as BOLD can help. Fine-tune the market and the target task. So these are all the approaches. It is not easy to address bias. Next, I'm going to talk about explainability. Explainability is at the intersection of cognitive science, AI, and HCI. and it is uh, it's it's an interdisciplinary science. So because you need to know who you're explaining for, to the expert, to the AI engineer, or to the end user, and you need to know how to explain to it, and you have to modulate your explanation to the actual user. So there is a lot going on in terms of explainability, and one of the effort that is spot on looking at this in a very comprehensive way is the DARPA Explainable AI program, which basically says today you are training data, you have a machine learning process, and you learn a black box, and then you probe the black box with various tasks, and out comes the decision. And the user goes scratching his head and says, "Why did you do that? Why not something else? When do you succeed? When do you fail? When can I trust you? And how do I correct an error?" So the XAI program basically figures out. It tries to develop models in an explainable fashion, and there is an explanation interface which says, "I understand why, I understand why not, I know when you succeed," etc. And I'm going to skip over some of these things. Explainability is a super active research area. There's tons of paper. Evaluation is also a big area of research. Basically, how do you evaluate the explanation given by an AI system? And DARPA effort is concluding this year. It'll be interesting to see what comes up with. I'm going to skip through some of these regulations. There is a lot going on in the regulation. This is there was an executive order by Trump just before he left office, and it basically lays a framework of the principles that AI systems should have, sort of like the SLMR principles that I talked about. And they were exploring non-regulatory approaches to AI, and fundamentally they were saying each agency should approach this thing. In the area of privacy, GDPR has a lot of protections for that's the European Union efforts to protect privacy of individuals. There is a big research area called differential privacy. You can go and look it up. It's basically, the idea is, how do you take data and throw in some random noise into it so that you protect the privacy while ensuring that the statistical properties of the data set is maintained. And NIH has done similar things with the COVID-19 data. Some of the agency-specific approaches, I'm going to just skim through it. HHS basically have published their own strategy, and they are and you can see that they want to promote trustworthy AI use and development. The FDA has come up with this set of regulations. They call it the artificial intelligence and machine learning based software as medical devices, or SAMD. And fundamentally, basically, they said that in order for you to get FDA approval, you need to publish the mechanism by which you're going to update your model. It's not once and done. The model is continuously going to evolve. So they wanted to ensure that you also you need to get approval on how you're going to modify the model, as well as it needs to be explainable, and it needs to be trusted, and you need to perform correctly, etc., etc. And the Federal Trade Commission, who's charged with protecting consumers, they basically say you need to develop your AI program to be transparent, explain the decision, ensure the decisions are fair, and be accountable for the decision for ethics, fairness, and non-discrimination. And last but not the least, the people who are worried about the gig workers, Saf Savage has actually developed tools which allows the gig worker to examine the work and figure out if they're going to make fair wage. So this is a way to address the problem of underpaid gig workers. In conclusion, I'm going to say that AI has unbelievable promise in healthcare, but the major concerns are privacy and ethics, bias in data sets, transparency, explainability, and trust. And government regulators are struggling to keep up, but there is numerous state and congressional efforts are underway. And this is people are finally realized that the promise comes with its own set of problems, and it's time to address those problems. And as the Chinese saying goes, may you live in interesting times. Thank you. Now I'm open for questions.